All right. This section is 5.4, properties of logs. And this is a very easy section. Once you get the hang of it, it should be very simple. But it's a very important section. We have to know these properties really well before we get to the next section, which is all about solving equations. And that's the whole purpose of being able to use logarithms to solve log and exponential equations. All right, so we'll start off with the quadratic property. Because a logarithm is a power, it's related to the exponent rules. So these properties are related to, very similar to the exponent rules. All right, if we have log base b of two terms that are being multiplied together, then we can rewrite that as log base b of u plus log base b of v. And the rules for when we're multiplying things together, just that have, when we have the same base and they have exponents, if the bases are the same, then all you do, the rule is you add your exponents. And so addition goes with multiplication, all right? And so here's an example. If we have log base 2 of 7x, we can split that up into separate logs with log base 2 of 7 plus log base 2 of x. Now in these properties, we may have a situation where they're written separately and we need to condense them down to a single log. We may have situations where they are a single log and we need to split them up. So these will go either direction depending on the situation that we have, all right? So then we have quotient property. When you divide terms that have exponents, when the bases are the same, you subtract your exponents. Same thing here. If we have log base b of u divided by v, we can split that up. It's the same thing as log base b of u minus log base b of v. Now, another way to think about it is things with negative exponents move, you put them in the denominator to make them positive. So the stuff on the top is positive, the stuff on the bottom has a minus in front of it. That's another way to keep it straight. So if we have log base 3 of m over 8, it's the same thing as log base 3 of m minus log base 3 of 8. The power property, when we have exponential problems, when we have a base raised to a power and then that is all raised to a power, then you multiply the two exponents, the one inside the parentheses and the one on the outside where it's been raised to, you multiply those. So with logarithms, if you have log base b of u to the n, then the exponent of n moves down to the front and gets multiplied by the logarithm. So we have n log base b of u. And so here with a numerical example, we have log base 5 of 3 to the 4th, then that exponent of 4 is going to move to the front and just be multiplied by the logarithm, okay? And now, for those of us who have, get started. All right, those of us who have an 83 calculator, or like me, the one that I have, I pull up here, it is an 84, but it is an older version, and so it doesn't have that little feature about where you can do math, alpha, math to get the little log. We don't have, if you don't have a Casio that has a little key where you have a little subscript square and then a square to fill in for the whatever you're taking a lot of. If you can't get to this in your calculator, like I can't do it in the one I pop up here, and I have a TI-83 at home, it doesn't have this feature in it. So to get around this, we have this formula, and it's called the change of base formula. And so this allows us to be able to enter logs in the calculator and find the values, especially when we're graphing. And so we talked about that the other day in the notes when we were doing 5.3. But you, if you have log base b of n, so then it is going to be the LOG button, just a plain log button on the calculator that all calculators will have that are scientific. You have log of n divided by log of the base. So it's the log of n, which would be the tall number, divided by the log of the base. And so the base goes on the bottom. Okay. Now, if you have the special features in your calculator where you can just do math, alpha, math, then you don't have a need for this formula. But if you don't, this is when you would use it. So if I want to know what is log base 3 of 7, the only way I would be able to get that in my calculator is to do log of 7 divided by log of 3. So the base always goes in the bottom. So log of 7, which is the total number, divided by log of the base. Okay? Now, in these examples today, some of them are going to have us expand, or in Pearson, it might say express as the sum of logs in this case, or express as the sum and difference of logs, or whatever the case may be. And then we'll eventually get to problems that say rewrite as a single logarithm. All right, so but right now, we have a single log, and we want to write it as multiple logs. Okay, so we're going to expand this, and each value gets its own log. So here I have log base 5 of 8 times x. So this is multiplication. Multiplication goes with addition. So I can rewrite this as log base 5 of 8 plus log base 5 of x. And so we're not really going to be simplifying or doing anything with this. This is getting us ready for the next section. Really, that's all this is. So just kind of easing us into the next section. And properties, if you don't learn anything about logarithms, you really need to know the properties. They're very important. All right, here we have a problem, and in this problem, we have exponents, we have multiplication, and we have division. So all three of the properties are rolled up into this one problem. So we're going to express this as the sum and difference of logs. So we're going to have multiple logs. When I look at this problem, I see division. And then I see I have a 7, an x, and a y. Okay, so that's 3 different items, and each of those should get their own log. So when I finish, I should have 3 logs in the problem. Okay, now I'm going to do this step by step, but after you get the hang of it, you can just go straight from this to the final answer. All right, so when I look at this, I see division. So I would rewrite this as log base 2 of the numerator, which is 7x cubed, minus log base 2 of the denominator. And so this is just y, log of y, so it's done. Now here, I have 2 things that are being multiplied, like I had in example 1, so I'm going to split those up. So this is log base 2 of 7 plus log base 2 of x, and this 3 exponent that is here is going to move to the front and be multiplied by the log. And then I have minus log base 2 of y. So now each value has its own log. I have log of 7, log of the x, and the exponent came to the front, log of y. And because the y was in the denominator, it has a minus in front of it. These were both in the numerator, so they're positive. Okay? All right, so this one says expand. So that means we're going to write it as multiple logs. So we have log base 5, and I have a 2 and an x. So I need to have 2 logs in my answer. Log base 5 of 2 plus log base 5 of x. This 6 exponent only goes with the x, so it moves in front of the log of the x. So it goes here. It doesn't go in front of the whole thing, because the 6 only goes with the x, not with the 2. So this is the answer. Okay. Now, this is natural log. It doesn't matter. It's a kind of log. It just has a different base. This base is e, where the other ones were 10s, or various bases. They had bases for them. So, but this one has an e for a base, but we do exactly the same thing we've been doing. So it's multiplication. So I'm going to write it as addition. So I'm going to use cursive. Natural log of 3 plus 5 natural log of e. All right. Now, the more and more we use these natural logs, you're going to learn. Whenever we have natural log of e, we said that this base here, when these are the same, that really, this just cancels and equals, like it's really going to equal the exponent, but I don't have anything here because it's just a 1. So natural log of e is always going to be the number 1. And so really, this is natural log of 3 plus 5 times 1 is just 5. This is not natural log of 8. It is natural log of 3 and then plus 5. Okay, because you have to do this operation first and then get that answer and add it to the 5. Okay. Now, this one has a square root in it. we want to change the way this is written, the square root of 5, and rewrite it as the square root as an exponent. So the square root of 5 is the same thing as 5 to the 1/2, because 1/2 means square root. All right, if I had cube root of, let's just say I had an x here, then that would be x to the 1/3. And if I had fourth root of x, that would mean x to the 1/4. Okay, and so another way to write a radical is just you write the variable and or the number, whatever's underneath here, and then this 4, which is the index, goes in the denominator. Now, if this had been let's say this was the fourth root of x cubed, then I would rewrite this. It wouldn't have a 1 right here on the top. It would have a 3. So if there's an exponent here, it would go in the numerator of the fraction of the exponent, and the 4 is the denominator of the exponent. Okay. So, but all we have here is square root. So we're going to rewrite this. So this is really log base 2 of 5 to the 1/2, and then x. So it's going to become 2 logs. So I have log base 2 of 5, and this 1/2 exponent moves to the front and gets multiplied by the log. And then I have plus log base 2 of x. And x was not under the radical, and it doesn't have an exponent like a 1, so this is the answer. Okay, now, here the directions change and they say condense. This is the same thing as if it said, like in Pearson, it may say write as a single logarithm. And so that means when you're done, you're just going to have 1 log in your answer. So I look at all of this. I'm going to write log, and these bases, there's not a base, and so it's understood to be 10. Now, when I look at this problem, I see addition and I see subtraction. The subtraction tells me I'm going to have a fraction, all right? So I'm going to have division. So I'm going to put a fraction bar right here. Notice it's not log of something over or whatever. The log is out here to the side. I'm taking the logarithm of a fraction. So the 6, this part is positive, so 6 goes on the top. This 2 in the front is going to move, because everything is going backwards now. This is going and becoming the exponent of this 2. And because this is positive, it's also going in the numerator, and it's going to be multiplied by what's already here. So then I have 6 times 2 squared. So the number in front of the logarithm moves and becomes the power. These were both positive, which meant they went in the numerator of the fraction. And I'm multiplying together, and now I have this log of 3, so the 3 is going to go, it's a minus, so it's going in my denominator. But now these are real numbers, and I can actually square this, multiply, and divide. So this is really 6 times 4, which is 24. 24 divided by 3 is 8. So this equals log of 8. Okay? All right. Here we have, I still have subtraction, which tells me I'm going to have a fraction. So this 2 is going to move here and become the exponent. This 5 moves here and becomes the exponent. So I'm going to have 1 log, and it's log base 3. Then I have a fraction bar right here in the center. And so this is going to be 7 squared, because that's positive. And since this is the negative, that meant x to the 5th goes in the denominator. Now, 7 squared we know is 49, so I think it looks better to write this as log base 3 of 49 over x to the 5th. Okay. Right now, we're condensing this. It's natural logs, but it works the same. So we have natural log. I see I've got, this is positive and these are negative, so it's another fraction. This 3 is positive, this is all positive, so it goes in the top. This natural log is negative, so it means 8 goes in my denominator. This 4 is going to move here and become the exponent. Now, I've had the question before, if I move this 4, am I moving a negative 4 or a positive 4? Well, if you say you're moving a negative 4 and you put negative 4 right here, and if you had x to the negative 4, since this is if you put, didn't have If you move the negative with the exponent, then this would be a plus, which meant this would go in my numerator. But I don't want to have any negative exponents, so then I would flip it and put it in the bottom. All right? So it doesn't matter whether you say the negative goes here, you're still going to have to move it to the denominator. So I usually just, because it's negative, I know that. That means it's going in the denominator, and I wouldn't move the negative with my exponent. Okay? So I'm going to write just x to the fourth. Okay? And that's it. Can't do anything with that. Now, I added this extra example down here because when we try stuff like this, usually some people get mixed up. So I use capital this time, so I'll print this. I have positives and I have negatives, so I have a fraction. The 7 is positive, so it goes on the top. This 2 moves and becomes the exponent of the g. But this is a negative, which means g squared goes in my denominator. This 5 moves and becomes the exponent here. But this is a negative, so it means it goes in the denominator. So I put x to the 5th here, and these are multiplied together. This log is positive, which tells me that this y is going to go in the numerator. And so it's multiplied by the 7, which is already up here. So this is really the answer. Natural log of 7y over g squared x to the 5th. Okay, so positive logs, the stuff goes on the top. Negative logs, the stuff goes in the denominator. Okay? Now, this is change of base formula. If I was going to put this in the calculator I have here, I would have to do log of 11 over log of 3. So the base goes in the bottom. And so in my calculator, pull this up here, I only have this log button. And if I do math alpha math, it doesn't show me the little log with a little subscript and stuff. So I would have to do log of 11, close my parentheses, divided by log of 3. And when I press enter, it gives me those long decimals. And I think Pearson usually has you round to 4 decimal places. So this is actually 2.1827. All right. Now, I'm thinking I skipped something I wanted to say. I haven't got to yet. Okay, so there we go. All right, it's this part. All right, remember how I told you when we learned that if this x was not here, it was in section 5.3 that log base a of a, when these are the same, the answer was just 1. But I told you what we're going to see is really whatever this power is, that's going to be the answer. All right, so if the base and this number, this term, this value, whatever it is, are the same, then that's really just going to make all this cancel, and the exponent is the answer. Okay, like if we have log base 7 of 7 to the 4th, then really all this just cancels, and we're left with 4, which is the exponent. All right, now when you see problems like this, even in Pearson, you have to pay attention. This a is the base, and this logarithm is an exponent. That's why it should look smaller, and it is raised. Okay, so this a is raised to the power of log base a of x, which I know that sounds kind of crazy, but that's what it is. So people have a tendency to overlook this and not pay attention. All right, but this is really, if this base and the base of the logarithm, which is part of the exponent, if this is the same, then really all this goes away, and this value right here is the answer. Okay, so like in this part, we have, this is 15 raised to the log base 15 of 4. So all this logarithm is the exponent. But because this base and the base of the log are the same, this all cancels, and we're left with just 4. All right, now let's see how to use it. Okay, here I have log base 3 of 9 to the 4th. So when I look at this, I see that these are not the same base. So I'm going to rewrite this. But before I do it, I want to say, if you have the calculator that has either the Casio or you do it in the graphing calculator, and you have the little log, the little box here and the little box here, then to type this in and do it correctly, this all goes inside. I think on the graphing calculator or Casio one, it's going to have parentheses here. So you're going to have log base 3, and then you'll have a box or a parenthesis or something, and 9 to the 4th goes all inside of that. It's not 9 with 4 on the outside. You get the wrong answer. Okay, so I almost did the inside, but we're going to actually use the properties and not the calculator. So this is log base 3, and if I rewrite 9, that is 3 squared. And then I already had this 4 as an exponent that was already here, so this 2 I just put here gets multiplied by the exponent that was already there. So this is log base 3 of 3 to the 8th. And so now that this base and this base are the same, I can mark all this out, and the answer is 8, because 2 times 4 is 8. So you're left with just the exponent. All right, next one. Now, you can double check this in the calculator to be sure, but just to show you how to work this out by hand, this is log base 2, and then 8, I need to write it as 2 to some power. 8 is 2 to the 3rd. And then I already have a 5 exponent here, so the 3 gets multiplied by that 5. So now I see that this base and this base are the same. Mark that out, and this answer is 15. I'm multiplying. Okay. All right. And then these are just some I added at the end because I usually have some questions about this. So in this problem right here, I think this is just review questions. I see a log base 5, and I have addition and subtraction. So I'm going to write log base 5 and then a division bar. So this 1/3 moves up here and becomes the exponent of the x. So it's x to the 1/3. This 2 is going to be the exponent of the y. It's the positive, so it goes on the top. Y squared. And now this is negative, so it's going into the denominator. The 4 becomes the exponent of the x, so this is x to the 4th. Now, when I look at this problem, I see I have an x for a base here and here. So I need to combine these together. And so this is exponent rules, all right? And so when you divide, you subtract, which means I'm going to have x raised to the 1/3 minus 4. Okay. 1/3 minus 4, if I take a third away from 4 wholes, it's going to leave me 3 2/3. So this is really x to the 3 2/3, but we wouldn't write a mixed number. We would write it as an improper fraction. So this is 3 times 3 is 9, and then add the numerator, that makes 11. So this is really x, and it's a negative. This is x to the negative 11 thirds. Okay. Now, because I ended up with a negative exponent here, it tells me my x is going to be in the denominator. So this is going to be log base 5 of y squared over x to the positive 11 thirds, because I'm moving it from, so this is in the numerator, and then that's negative, so I put it in the denominator. Now, if the y squared had already been down here, and I moved this x down here, there would be a 1 to let people know that all this is in the denominator. So I have to put a 1 here to show that that's what was left on the top. Okay. Now, some mathematicians think that it's better to leave it this way than to write it as a single x. And so when you're doing your homework, just read the fine print and see what it says. Okay. Now this last one, this is where we're really going to be headed as we get towards to solving equations. But we have a log of something minus a log of something. So they both have log base 7, so I write log base 7. And then I have, this is positive, so all this goes in the numerator, x squared plus 5x plus 6. This is the minus, which means this goes in the denominator, x squared minus 4. Now, after all we've done in the semester, when you see this, you should think, factor, factor. And so this is going to be log base 7. And so this numerator factors into 2 parentheses, x plus 3, x plus 2, because 2 times 3 is 6, and 3 and 2 have to be 5. And then the denominator is x plus 2, x minus 2. All right? So then when I look at this, I realize, oh, they both have an x plus 2 that's being multiplied here, so I can cancel this one in the numerator with the one in the denominator. And so then I'm left with log base 7 of x plus 3 over x minus 2. And that will be that answer. Okay, and we'll be doing some of this kind of stuff when we get to solving equations. All right, and then I believe that is it. Yep. All right, so really this is not a bad section. It's just about properties, moving stuff around, spreading it out with multiple logs, condensing it back to a single log. All right.